So for part one, we're going to begin the planning process. And the first stage of this is weather and conditions. So just from the previous video, there are three stages we need to look at for each of these phases. So the planning phase, we need to look at weather and conditions, you and your party's skills and experience, and the landscape we intend to visit before we then go on to your journey in key places. So we'll start off looking at the planning and, most importantly at this bit, the avalanche hazard, weather and mountain conditions. So on your app, you can open up the home screen, go to plan and evaluate. We're going to be looking at the planning stage, and it will open up this screen here. And again, we've got the weather and conditions, you and your party, and mountain and landscape. There's a lot of information on these sections. What I'm providing is a little bit of complementary information and a little bit more surrounding it, and just kind of showing you how the app kind of works really. It's given you these three pointers here, weather, you and your landscape, at the top of most of these stages in the app, just to really drum that message home. So planning is the most important phase of going out in winter. I spend most of my time in the evenings before going out for the day planning where can I go, where is going to be safe, what routes can I choose, what can I achieve that I need to achieve for this particular day and the particular group I'm with. All of that happens the evening beforehand. So when I'm out on the hill, I'm then thinking about my journey. Is the weather doing what I'm expecting it to do? What about the people I'm with and the landscape I'm in? Have I made the right decisions? And never be afraid to turn back. But if you do your planning in as much detail as possible, you should hopefully have a very good day out on the hill. First question, is there snow lying on the hills and mountains? If there is, expect the risk of avalanches in many locations. So what can we do? We can read published avalanche reports and consider weather forecasts for wind, precipitation and temperature. Each of those three, wind, precipitation and temperature, can have a massive impact on avalanche risk. In our app, we can look at hazard levels and advice. We're going to come on to that later, but let's just look at where we get this information from. I'm sure you're all familiar with MWIS. They cover a range of different areas in England, Scotland and Wales, and they provide very, very detailed forecasts. They are extremely good and valuable. They don't provide you, however, with what's happening during the night, which can be very useful, certainly in winter. Met Office provides specialist mountain forecasts, again for a range of areas, and a lot of very useful information. I often compare MWIS with the mountain area forecasts to start building up a picture, kind of building up an average. There are also apps. So the Met Office have got their own apps, and also on their website you can search for places and particular summits. So here we've got Ben Macdui. One thing to note really is they don't have every summit. They tend to include the most popular summits or the highest in a particular range. So for Glencoe you will get a summit forecast for Bidian Nambian, which is the highest in Glencoe, but not for Skirnahooli, for example. But they're very, very useful. They give you a lot of hourly information here. So we've got what the sort of clouds doing, the temperature at the summit, as well as the chance of precipitation. We scroll down, we can get the wind forecast per hour, the general wind speed, the gusting speed and what direction it's coming from. And also very useful in winter is when the sunrise and sunsets. You can see here we haven't really got many hours of daylight to play with. And also very useful in summer is the UV forecast. So another app that I like, which has also got a website, is yr.no. It's a Norwegian weather service. Just like the Met Office, you can search for particular summits, and it's also got a very useful set of forecast information that it gives you, such as precipitation, wind speed and so forth. A peculiarity of it is that it gives you the wind speed in meters per second, but you can go into settings and change that to miles per hour for those of us that are more used to that unit of measurement. So I tend to take an average of the weather forecasts and try and build up a picture. They've all got their own little quirks and peculiarities and interpretations. Bear in mind, these are forecasts. They're what we expect to be happening, and different people will come to different conclusions. On the whole, they tend to agree with each other. It's not often that they completely fall out. In Scotland, we've got the wonderful Scottish Avalanche Information Service, and they are very good, and they provide you with avalanche forecasts in a number of key areas. They produce very detailed reports with a lot of information here. In fact, there's so much information, the next video is dedicated purely to going through what this information is telling us. If you live in the Lake District, you have the Felltop Assessors, and they will go up on Helvellyn every single day and tell you what's happening. So they will produce an avalanche risk. It's extremely useful. It's not the highest mountain in the Lake District, but it's possibly the most popular, certainly in winter. You've got Brown Cove Crags, which is also a nice little climbing venue. And it is well worth having a look and then inferring what's happening on the other mountain ranges. Which is great if you live in the lakes or previously in the Scotland, but what about in the Yorkshire Dales or Peak District or Snowdonia? Well, you have to basically apply everything that we're going to be covering, the whole Be Avalanche Aware process, to what's happening in those particular areas. And questions that you are asking is, what has the weather been doing? Has it snowed? How windy and from which direction? And what has the temperature been? So have we had freeze for thaw cycles that's consolidated the snow? And then also look, this is part of your planning process, what is the weather going to be doing? All of this will help you build up your picture for where you are going to go for your trip. So we've looked at that first point, while bringing in that weather and getting the forecast and so forth. Wind above speeds of 15 miles an hour will transport snow and form unstable wind slab. So wind slab is a cohesive layer of snow formed when wind deposits snow onto leeward or sheltered terrain. Wind slabs are often smooth and rounded. They sometimes sound hollow when you walk on them, and they can appear chalky white. We'll look at wind slab later in a bit more detail, because it's very, very important. It's a very common feature you see in the Winter Mountains in Britain. And we can also then check the map using the wind direction, work out where new snow will probably lie. It will usually form in a range of sheltered or lee slopes. And we can read the avalanche report text carefully to determine the places where new and unstable snow may be accumulating. So where this snow is accumulating thanks to the wind, this is where we are likely to find wind slab forming. In our app, we can look at hazard levels and advice, and also terrain considerations. So let's do this now, because I think it's a good time to bring these in. So we're in the weather and conditions. We're looking at the windy section. So again, as part of the Be Avalanche Aware process, they've got this information here. They've also got some other pictures and videos that you can look at. If you go to the top right hand side, you will see 3 bars. If you click on that, sub-menu appears, and we have terrain considerations. If you just open your app from the home screen, again, terrain considerations is shown. So let's take a hypothetical example here. We're going to use this hypothetical example throughout this video series. So let's assume overnight we have got 15 mile an hour winds coming from the southwest. Well, 15 plus mile an hour, so could be 40, could be 50. It's coming from the southwest. This is the most predominant wind direction that we get in Britain. Southwesterlies comes from the southwest. So what this is going to do overnight is it's going to redistribute snow from the southwest slopes onto the northeast aspect slopes. And in the morning we have got that wind exposed southwest ridge. And what it has created is a cornice on the northeast side as well as deposited snow. So there's a reason I've given kind of three altitude markers here. We'll come on to this shortly. But 600 metres down here is kind of like roughly the start of the snow line. That exposed southwest ridge, we can have a really nice day out on the mountains. However, on the lee or northeast slopes above 900 metres there is a considerable avalanche risk. And below that, between 6 and 900 metres, there is a moderate avalanche risk. So this is quite a confusing picture. So what we can do is just represent that pictorially, and this is what the Scottish Avalanche Information Service do. So again, we've got our three altitude layers here, and we're showing the risk here on the north through to easterly aspects. So the wind has been coming from the southwest. It might have varied a little bit. You tend to get variations where it hits corries and wind going in all directions. So it kind of covering the just beyond also the northeast area. So we've got our 900 metre there, above which there was considerable. We're going to look at the avalanche rows in a little bit more detail later on, because it's quite important. But this is looking at some of the terrain and what's happening with wind. So, hazard levels and advice. I've just mentioned considerable, moderate and low avalanche risks. So what does this all mean? So again, from our sub-menu, we can then have a look at hazard levels and advice. You can also get that from the home screen of your app. And also, we're going to cover this here because it's quite important. Avalanche problem descriptions. So what kind of avalanche risks are there? What are the real risks to be looking for as part of these hazard levels and advice? So this is a European scale. It might be global, I'm not actually sure. We have a number of different categories. Very high, which I've never seen in Britain. I think there's probably more in the European Alps that you get this kind of an avalanche risk. But we do get high avalanche risks. Natural avalanches will occur and a single person load will trigger an avalanche on some slopes. Good visibility and route finding in mountain terrain is essential, as is experience in avalanche hazard evaluation. You should be aware of and avoid run-out zones at low altitudes. So that's really below that avalanche risk area. Where is that snow going to basically dump itself? It's going to come to land somewhere. So you don't really want to be anywhere near an avalanche zone, and that's below it. It's vital that you manage your group carefully and use mountain features, e.g. ridges and protected slopes, to travel safely. So in that previous example we saw then there was a considerable avalanche risk, but we could still have a nice safe day out on a scoured ridge. So considerable natural avalanches may occur and a single person load is likely to trigger an avalanche on some slopes. So again, you want to have good visibility, route finding, and this has all come into your planning really. Where can you go and walk? So considerable risk, moderate risk, human triggered avalanches are possible. So it's possible, and you can get a little bit blasé about moderate risks or even considerable risks really sometimes, and we do hear stories of this. You know, if I said to you, let's go to a pub, okay, so we'll go to the Locomotive, which is actually at the end of my street. There is a moderate chance that someone's going to punch you in the face. You probably wouldn't want to go to that pub yet. Sometimes people go, oh yeah, it's just a moderate risk, we'll be fine. I take avalanches very, very seriously. So moderate risk is still, you know, something that I'm very, very aware of and conscious of. Even a low avalanche risk, well, there could be peculiar different terrain types that can still cause problems depending on what weather's happening. So it says human triggered avalanches are not likely. What it doesn't say is impossible. So it's saying there is still a chance it could happen. So this avalanche rose. So 600 meters. These will vary. They might even vary daily. But the first one you'll see is normally the snow line or the usual access altitude. The middle one is the altitude of hazard transition, and this can also vary daily depending on where you are. And the top one here is the highest point in the area, kind of roughly. So the transition area is kind of between where you've got more gentle gradients, less chance of avalanche perhaps, and then you're moving into an area, this transition, where it might get more steeper slopes or the steeper gradients going up towards the summit or towards the crags. And note as well that in any particular mountain area or corrie, many aspects may be encountered. So for example, the north face of Ben Nevis and the northern corries of the Cairngorms contain most other aspects in addition to northerly ones. It's not just a cliff facing north. So it's got the ridges and spurs, which have also then got easterly and westerly aspects on them. So this is something you also just need to consider and bear in mind. Something else you might see quite frequently are these sort of tiger stripes. And what this means, and it will alert you to this, is there's a localized hazard. So what it means is there's limited snowpack cover and or weaknesses in the snowpack being confined to small areas which can release as an avalanche with a loading of one or more people. So even small areas, once triggered, can affect the whole slope because of the increased load and produce avalanche of serious consequence and greater size. So what it's saying is, so here, for example, there is a low avalanche risk, but there are little areas where you may get a moderate, and they will be confined to particular areas, and there'll be particular weaknesses. So again, we might be looking out for areas of wind slab, or has there been a little bump or dent in the landscape, which has just managed to accumulate a different amount of snow from everywhere else. There'll be peculiarities in these areas. So we looked at wind slab. Let's look at it in a bit more detail. It's a cohesive layer of snow formed when wind deposits snow onto a leeward terrain. So the wind gets lifted up, battered around a little bit, and it will produce quite a shiny surface area. So in your app, it demonstrates wind slab in this kind of way. It shows you that little wind chute and snow being drifted around. Understanding what has been happening to the snowpack during the weeks and the days before your trip can help inform you whether there are weak layers in the snowpack. So weak layers again shown in your app as persistent weak layers, this symbol here. So wind slab, you'll be able to identify it by that sort of hollow sound. You'll also get cracking. This can also be a sign of persistent weak layers somewhere in the snow. If these cracks kind of propagate from your feet or your skis, they can travel quite a distance, they can give you a hollow whomping sound, you want to get out of there very, very quickly. That's not a place that you really want to be. So we can also get, as another terrain problem, gliding snow. These are tension fractures appearing in the snow surface. Avalanche release is unpredictable in the short and long term. So if you happen to be on completely flat, you're probably not going to go anywhere. But the moment you start introducing a gradient, there could be problems. So the wind can have a massive effect on avalanche. It redistributes snow. And it can cause a lot of problems. Another thing that can cause problems is temperature. So low temperatures over a few days, freezing levels at 900 and below, produces and maintains instabilities in the snowpack, while warm temperatures and rain at summit levels produces rapid instabilities in the snowpack. So again, avalanche and weather forecasts will tell you what's happening. Where is the freezing level? What's happening around that one? And again, that's the hazard levels and advice. So warm temperatures in the snowpack, this can cause a lot of problems. You can kind of see it when you're out walking. Easily displaced snowballs will roll down and they'll actually gather. They'll gather more snow and become bigger as they go down. That's a sign of a warm snowpack, something that's above freezing. We may see it when we're out, we may not. I'll definitely point it out if we do. But you can tell wet snow because it tends to clump together. Surface grains, that's something that we want to be aware of. I've got a picture of that on the next slide. Signs of sparkling snow. If it stays cold and then you get another layer of nice fluffy stuff on top of it, you can end up with a very weak layer between you. And cornices, so this is something that temperatures can affect, or if it's suddenly got very heavy with a load of rainwater going through it, cornices can collapse. So what we want as winter climbers and mountaineers is freeze-thaw cycles that can consolidate the snow. Fresh powder is extremely difficult to walk through and climb on. It's obviously brilliant for skiing, but it's horrible for us lot walking through it or sometimes swimming through it. So these are things that temperature can have a big impact on. So a type of snow or the sort of rounded crystals that you can get is graupel. This is winter hail, and you can see it here. It's just basically a layer that has arrived. It basically had a load of winter hail, but it stayed very cold. And a few days later, we got some nice fluffy stuff arriving on that. So really what you've got is a nice layer of snow on a layer of ball bearings. You can imagine that's got potential for avalanche risk. So we want to know what's the temperature been doing. Graupel is kind of formed when you've kind of got that in-betweeny around zero freezing level. As the snow falls down, it may rise and fall a few times, and if it gets above freezing, it kind of slightly melts, picks up a bit of moisture from the atmosphere, and eventually just gets rounded off into a ball bearing. So these are the weather and conditions that we need to be aware of. So, you know, as a summary, is snow lying on the hills? Go and study a range of published avalanche reports and weather forecasts. Check the avalanche hazard table. Is it low, moderate, considerable, etc.? Wind. If it's windy, if it's above 15 miles an hour, there's going to be snow moving around the mountains. Wind can scour a mountainside and dump it on the other, leading to avalanche traps. Avalanches will happen at angles between 30 and 45 degrees. So on slopes that are 30 degrees to 45 degrees, you can expect avalanches, especially where there's been fresh snow dumped on it by the wind. Compare avalanche forecasts with a map for where the risks are and the angular slope. This is all part of your planning process. Is it cold or warm? So low temperatures over a few days and below can produce and maintain instabilities in the snowpack, whereas warm temperatures and rains at summit produces rapid instabilities. However, if it then goes and freezes again, brilliant, you've got a nicely consolidated snowpack. That will then capture and keep that layer as it was. All of those layers will suddenly, hopefully, be nicely contained. It depends. A lot happens. Yeah, snow interpretation is extremely difficult. That's why we tend to go to the forecasters for advice. So we look to get freeze-thaw cycles for snow consolidation. So if you get rain, it may only hit the higher levels, but it may still leave that layer of graupel at the bottom, those ball bearings, totally free. So it's a difficult thing to gauge. So use the forecasts. So that's it for this one. In the next video, we'll look at interpreting in slightly more detail the avalanche forecasts.